Hello everyone, let's find out the electric potential due to a system of charges. Let's assume that there are few charges, say plus Q1, minus Q2, minus Q3 and say plus Q4 at some separation, and let's find out what is the electric potential due to these charges at a given point P. So each charge, that is charge plus Q1, minus Q2, minus Q3 and minus Q4, each of this charge will create its own potential. Let the distances from the charges be R1 from the charge Q1, R2 from minus Q2, R3 from minus Q3 and R4 from plus Q4. So here each charge will create its own potential, and let that potential be V1, V2, V3 and then V4. So V1, V2, V3 and V4 are the electric potential which these charges create. We have learned that the electric potential is a scalar quantity. Therefore, the total potential, which I call as capital V, this is equal to just normal addition. That is, it is just scalar additions of the individual potentials. That is, in this case, we know that V is equal to K Q by R. So V here is equal to, it will be K Q1 by R1 plus of K minus Q2 because it has a negative polarity by R2, and then plus K minus Q3 by R3 plus K Q4 by R4. That is, V is equal to K Q1 by R1 minus K Q2 by R2 minus K Q3 by R3 plus K Q4 by R4. So this is the required electric potential at a given point. Now keep in mind that the reason that we adopted a concept of potential is to simplify things. Otherwise, at this point, the electric field, the net field would have been the vector sum of individual electric fields, and adding vectors is not easy task. It is little complex. So to avoid such problem, we have brought in the idea of electric potential which simplify things. So adding this, it's much easier than adding electric field. So the only thing remaining here is we need to convert the potential in terms of field, or we need to relate them. It's only task remaining. If that is done, the potential would be a simpler task to study the charge and its effects.